Hello everyone, today I'm going to show you how to fine-tune a LLaMa 7B large language model on your own GPU with the Ubuntu OS. So we'll start by making a Python virtual environment and switching to it, and then launching a Jupyter Lab server in that environment. In Google Colab, we paste the URL of the Jupyter Lab server into the field that pops up when you try to connect to a local runtime. Now we install some Python packages like accelerate, bits and bytes, and TRL, and we have to make sure that PyTorch, of course, is installed with CUDA compatibility. It recognizes CUDA, you have CUDA installed, and you have to make some special attention that the dependencies are not conflicting each other in their different versions. Now we want to run the notebook cells. For me, the training algorithm took 7 minutes with this dataset and model. The model we are training with is LLaMa 2 7B with 7 billion parameters, and it uses 13 gigabytes of space. The dataset is 1,000 samples of question-answer and instruct prompts in many languages. We use QLoRa and precision efficient fine-tuning to fine-tune the model without using too much memory. This was possible due to my Zotac Gaming Trinity RTX 3090 GPU. It has 24 gigabytes of VRAM and costs $900 to $1,100 on Amazon. I believe it's worthwhile to have a GPU for local prototyping if you will be using machine learning projects for the next 2 to 3 years. And 7B models can have good reasoning with like fine-tuning to have domain expertise. Now, if you want to build larger models, of course, you can use the cloud, but I think that having a GPU can be practical for different use cases like gaming, video rendering, modeling, so I think it's a solid investment either way. Typically, the 13B model is the largest model this GPU can run, but some projects can have memory optimization or quantization tricks to run 30B or 60B. When the model is done, you can upload it to Hugging Face. Hugging Face has an inference API to serve customers and an open source version called TGI. Other hosts include Amazon Titan, Google Cloud Platform, and NVIDIA NeMo. Costs range from 35 to 75 cents per hour of serving. So another trick we can do is change the model to GGUF form and quantize it to reduce the memory footprint when serving it. However, in this case, I'm just going to use transformers and load the whole file with the safe tensors and run it in something called WebUI for TextGen. And we get a token throughput of 33 tokens per second, and you can see that the model has pretty good reasoning with translating software requirements scenario I gave it into Portuguese. So I believe this model is a success, and I hope you learned a lot about how to provision, set up a local GPU to train and do machine learning tasks. You can find the links for both my Colab and for the Hugging Face in the QR codes. I want to thank you and have a good day.